So here we use a filter paper to separate the rice out of water, but I can use a strainer, which is much easier. So let me stir it a little bit. Okay. Look. So this method, we use it in our kitchens, but it works in chemistry. That's why at the beginning of this year, I told you that your mother, while she is cooking, I can assume that your mother is a small chemist. She's doing chemistry. Okay. So this strainer also, it's a type of filtration process. And this filter paper is a type of filtration process. Okay. Look. This is also another type of filtration process using a filter paper with a funnel. I can separate sand out of water by this method also. Okay. 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 And the name of the liquid that is moving and settling down at the bottom of the flask, the name of this liquid is filtrate, and the name of the insoluble substance that is trapped at the top of the filter paper is residue. So the sand here, its name is residue, the insoluble part, and the soluble part that is falling down as a liquid called a filtrate. So this is filtrate, and the one that is trapped on the top of the filter paper is called a residue, like rice or sand or whatever. So we call this residue. This is residue, and this is filtrate. When we separate the rice out of water, this is filtrate and this is a residue. Here, this is a filtrate down and this is a residue. So again, what is a filtrate? The liquid part of filtration. That's it. What is a residue? The insoluble part, like sand in our example here, that stays or trapped at the top of the filter paper. So till now we have taken two methods, decanting, and I told you that decanting is an inaccurate method. It can separate the particles, but inaccurately, about 7% its accuracy, 70 to 80%, and the filtration process by using a filter paper, which can trap the tiny particles at the top of this paper, but let a very small particles like the water particles to pass through it to fall down as a filtrate. Of course, the filtration process and the decantation process, both of them are used to separate insoluble particles out of water, but the filtration process is much more accurate than the decantation process. Now, the third method, or before taking the third method, let me try a soluble substance like a pigment. This is a rice pigment. I can add few, enough. This pigment is soluble in water. It is completely soluble in water. طيب. Okay. Oh, we don't have water. Okay. Wait. Okay. Again. So this is a solution. It's not a mixture. It is a solution because the particles are separated evenly as we said before. طيب. I want to separate it. Let me clean this cup. Okay. Wait. Okay. After a while, look at the sand particles. They are completely trapped. Look at the sand particles. They are completely separated from water and sticked on the filter paper. So this is called residue as I told you before. Now, let me try separating a soluble substance out of a solvent. Can I use filtration? I told you before that filtration is a process that is used to separate an insoluble substance out of a liquid. Can I use it to separate a soluble substance? Okay, let us try. This is a funnel again, and I want to add a filter paper, and I want to repeat the process, but in this case in this time, I want to use the red solution to see if this filter paper can separate the red pigment out of the water or not. Okay, let me try. Okay, I can use this one just because it's easier. This cup because it's easier. Okay, look. Okay, is it clear? Oh yeah, look. The particles of the dye, the red dye, is also very small, smaller than the spaces that are found on the filter paper. So they are falling down with the water particles to the bottom of the cup. So filtration is a process that is used to separate insoluble particles. I cannot use it to separate soluble particles out of any liquid. So can I use filtration to separate, for example, salt out of water? Of course not. Can I use it to separate a solution made of sugar and water also? Of course not. So filtration is a process that is used to separate insoluble substance out of a liquid. Now, let us do another method. Okay, but before that, look, where is the residue? Where are the insoluble particles? We don't have. This means that filtration cannot work with the solution, with the soluble particles. Okay, what about evaporation and crystallization? What are the differences between evaporation and crystallization? Let us look at the water particles here. Okay, this process is called an evaporation process. Why? Because we don't have bubbles. The water evaporates, so we have a water vapor, but you cannot see it by this video. You cannot see it clearly, but try it at home. So the difference between evaporation and boiling: that evaporation, the water particles are evaporated from the surface of the solution. The water particles do not evaporate. The water particles do not evaporate from the bottom of the container, only from the surface of the container. But look at the boiling process. This is, oh, it's hot. Okay, this is the boiling process. Look, first of all, here we have bubbles. we don't have bubbles. So again, here, we don't have bubbles. The particles are evaporated only or are evaporating only from the surface of the container. But here in the next other one, we have water bubbles and the particles